Hi, hello friends, welcome to our channel Study of Mathematics.
Good morning. Today we will discuss about the topic integers. First, we know about the definition of integers. What is mean by integers? Integers is nothing but a set of whole numbers, the set of whole numbers includes with negative numbers. Set of whole numbers include with the negative numbers are called as integers. In previous video we'll discuss, we already know about the topic whole numbers. What is mean by whole numbers? The set of natural numbers includes with 0. The set of natural numbers includes with 0 is called as a whole numbers. That whole numbers set we denoted by the letter capital W, and that W is our set is equal to 0, 1, 2, 3, and so on. These are the whole number set. That means these 1, 2, 3, and so on are called as the natural numbers, and 0 which includes the natural numbers. This is called as a natural number, that is capital N, and capital N includes with 0, we get the set whole numbers. And next, the integers is nothing but the whole number set includes with the negative numbers. Whole number set include with the negative numbers are called as a integers. These integers are denoted by with the letter capital Z, and that capital Z is equal to in infinity minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. Here from 1, 2, 3, 4, and so on are called as a capital N, that is natural numbers, and from 0, 1, 2, 3, 4, and so on are called as a whole number, that is capital W. By including all these with the negative numbers, these negative numbers is nothing but the negative signs of the natural numbers. Already we know natural numbers are starting from 1, 2, 3, 4, and so on. All the natural numbers are positive numbers. All the natural numbers are positive numbers. That positive numbers negative sign, that means the minus 1, minus 2, minus 3, and so on are called as a integer set is also a infinity number of elements are there. In this integer set, we divide this integer set into three parts, that is positive integers, negative integers, and the number 0. That means positive integers are start from 1, 2, 3, 4, and so on. These already is equal to the natural number set. The set of natural numbers are nothing but a positive integer set. That positive integer set is denoted with the letter Z plus, and negative integer set is Z minus, that is equal to minus 1, minus 2, minus 3, minus 4, and so on. Here these are the negative integers and these are the positive integers. In between 0 is there now. That 0 is has neither positive nor negative. That means a 0 has no sign. That means 0 is not a positive number and not a negative number. 0 is a fixed number. That means 0 has no sign. That means that 0 has a either not positive number, it is not a negative number. And in next we discuss about the properties of integers. That properties are the first property is integer satisfies closure, associative, commutative property under addition and multiplication. Already we know what is mean by closure property, what is mean by associative property, what is mean by commutative property in previous video. According to third properties, for integers also satisfies closure property, associative property, commutative property, and addition and multiplication. Closure property is nothing but a, for example, you take any number in the set integers. Integer set is denoted by the letter Z now. That's why a number A, I'm taking it as a capital Z. Then closure property means under addition, if you take the numbers 2, A comma B, then A plus B is also belongs to the set Z. That is closure property. According to the addition, according to the multiplication, A into B is also belongs to Z. That is closure property, associative property, commutative property. Already I will discuss. According to that, we have to prove this also. And here integer satisfies distributive property. Distributive property also we know in previous videos. That means distributive property and multiplication and addition is satisfies. Here the two more properties are inverse property and identity property. Here we discuss about the inverse property and identity property for according to the integers. This inverse property and identity property is under addition we satisfied and under multiplication also we satisfied. How we will discuss here. And first we discuss about inverse property. Inverse inverse property for set of integers. Then for this, first we take any number in the set. I am taking small a belongs to the set of. Let you take the number. Let a belongs to the set natural numbers. Already we know in the integer set we have positive numbers and negative numbers. If a belongs to z, we know that minus a is also belongs to the set z. Then if a plus of minus a is equal to 0. That means the numbers a and minus a, the addition of the two numbers is equal to 0. Then this property is called as an inverse property for that integer set according to the addition. That means if any number a is there, then that negative number, if we add, we get the 0. Here a is inverse of a is inverse of minus a, and minus a is inverse of a. And according to the multiplication, in the same way, a belongs to z, a belongs to z, a belongs to z, and by multiplying any two numbers a comma b or any two numbers, by multiplying a into b, we get the number 1. We get the number 1. Then here b is called as a inverse of a and a is called as a inverse of b. If any two numbers multiplication is equal to 1, then the two numbers are satisfies the inverse property according to the multiplication. If any two numbers addition is equal to 0, then the two numbers are satisfies the inverse property according to the addition. And next property is identity property. Identity property. That means identity property is nothing but if a number a is in the set z and already we know 0 is in the set z, then by adding a with 0 we get the number a only. That means if take any number we add with 0, we get the same number. Then here 0 is called as a additive identity. 0 is called as a additive identity. Additive identity. And if a is in the set z and we know 1 is in the set z, if we multiply any number with 1, we get the same number. That means a into 1 equal to a. Then here 1 is called multiplicative multiplicative identity. Multiplicative identity. That means if any number is add with 0, we get the same number. Then 0 is called as a additive identity. And if any number is multiplied with the letter number 1, we get the same number. Then 1 is called as a multiplicative identity for integers. Next, we will discuss about the rational numbers. In the chart, previous video, one chart is there now. The chart, the next topic is rational numbers. For knowing the rational numbers, first we know about the what is mean by fractional numbers. What is mean by fractional numbers? That means if any fractional numbers, the fractional numbers are known as a, if any number can write as a P by Q form. Any number can write as a P by Q form. That is a fractional number. In this fractional number, P is called as a numerator and Q is called as a denominator. And the some of the properties or some of the rules of that fractional numbers are the fractional numbers are converts into decimal form. That means if any, for example, 1 by 2, 1 by 2 is a fractional number. Here 1 is a numerator, 2 is a denominator. The value after calculating 1 by 2 value, we get the number 0.5. The value of 1 by 2 is 0.5. This 0.5 is called as a decimal form. The fractional, every fractional number we have the decimal form. This decimal form as terminated decimal forms, non-terminatal decimals, repeated decimals and non-repeated decimals. That means this decimal form is there. Now the decimal form is a four types that are terminating decimals, non-terminating decimals, repeating decimals and non-repeating decimals. First we know about what is meant by terminated decimals. That means terminating decimals has no end digit, no end is is an end digit terminating. That means the end point is there. For this, for example, 1 by 2 you take, the 1 by 2 value is equal to 0.5. Here the last digit is 5 only. There is no repeated value or there is no values. And for example here 0.1 0.15432, there is end point is there, that is end digit is there, that is 2. And 0.83823, here also end digit 3 is there. And 0.25, here also end digit 5 is there. 0.50, here also end digit 0 is there. In that type of decimal forms are called as a terminating decimals. And second one is non-terminating decimals. Non-terminating decimals are the one that does not have an end point, does not have an end point. Here end points, end digits are there na. In this type non-terminating decimals, we have no end points are there. For example, 0.54444 is repeated, 4 is repeated. And 0.12345, here 5 remaining numbers are repeated. 0.33333 and so on. For example, you take 1 by 3. How to convert this fractional into decimals? How to convert these fractionals into decimals? That means you divide, 1 with 3. 1 with 3. That means here no, that means 0 point, here put 0, 10. 3 3s are 9. Here 1. Point is there now, put 0. And again 3 3s are 9. Remainder 1. The remainder 1 is repeated. Here 3 is also repeated. That means 0.33. There is no end points at the decimals. Then that type of decimal numbers are called as a non-terminating decimals. And repeating decimals are in that these are also non-terminating decimals, but same number is repeated. Here in non-terminating numbers, same number is repeated in some cases, but repeated numbers are not there, but repetition is there. That means end point is not there. For in repeating decimal numbers, only some numbers, here 0.666, only 6 is repeated. Here 0.123, 123, 123, again 123, 123. Here 123 is repeated continuously. The type of uniformly repeated uniformly, that means same numbers are repeated in the same way, that is called as a repeating decimals. And non-repeating decimals or the one does not have no repeated terms. That means non-repeating Decimals are one that have no repeated terms. No repeated terms. But these are the non-terminating decimals. But there is no repetition there. There is no repetition is there. Uh, Next, we know about the rational numbers. What is meant by rational numbers? The definition of rational numbers is any number which can be represented in the form of P by Q, then P by Q, where here Q is in denominator. That denominator must be not equal to 0 and P comma Q belongs to the set Z is denoted by the letter capital Q. The rational numbers or the rational number set is denoted with the letter Q and that Q set, the set of Q is write it as a in the form P by Q such that here P comma Q are in the set Z and Q is not equal to 0. If P is equal to 0, that is not a problem. But Q means in the denominator term that must be not equal to 0. That type of fractional numbers are called as a rational numbers. And what is meant by rational numbers means in real number set other than the rational numbers are called as a rational number. And most important definition is non-terminating and non-repeating decimals are said to be an irrational numbers. And here irrational numbers are indicated with the letter Q bar. Q bar. That means irrational numbers are non-terminating. That means non-terminating and non-repeating. There is no end digit is there, but in the end decimals there is no repetition also there. End digit also not there, repetition digits also not there. The type of fractional numbers, that type of fractional numbers are called as a irrational number. Mostly irrational numbers are the square root values. Exact square root values are not. The square root 2, root 3, root 5, because here root 4 is not belongs to set Q bar, because the root 4 value we know, root 4 equal to 2. That means 2 is an a set of Z. That means 2 is nothing but a 2 by 1. Then the perfect roots are not irrational numbers. Other than the perfect roots are called as irrational numbers. Root 2, root 3, root 5, root 7, root 6 and so on. Or some of the examples are root 2 equal to 1.4142135. Here there is no repetition is there. But there is no end digit also not there. And here pi, this is a constant value. Pi is nothing but a 22 by 7. We have one doubt. మీకు ఒక డౌట్ రావచ్చు ఇక్కడ 22/7 is in the form P by Q, but this is how non-terminating and non-repeating decimals. ఇక్కడ decimals లో repetitions ఉండదు ప్లస్ terminating decimal non-terminating అంటే non-terminating అంటే దీనికి ఎండ్ డిజిట్ అనేది మనం కనుక్కోలేము అనమాట. అటువంటి వాటిని ఏమంటాము ఇర్రేషనల్ నంబర్స్. రూట్ 3, రూట్ 7, root 10, root 11 and so on are there. These are the irrational number. Thank you for watching. We will see in next video.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.